Audio.
All right. Hello, everyone, and welcome to our webinar. My name is Krzysztof Pietro. I'm a business development manager at Ambient System, and I'm here today with Michał, product manager, also one of the best experts on the intercom systems that I know.
Thank you. Before we start, we have to check if our audience can hear us and see us. I believe that everything's fine, but please write us a message via chat to assure us that everything is fine with technical, let's say, services that we are using. I'll just quickly check the chat. I hope someone will
Let us know.
let us know exactly. All right, everything is fine. Thank you, Stanisław.
All right, okay, so we're here to discuss some IP intercoms in real-life situations, hopefully offer you some good insights. Thank you for joining the webinar. We are really super happy to have you here with us. And before we start, some general information. The webinar will take about 45 minutes, maybe 50 minutes. If you have any questions, write them down in the Zoom chat, and we will answer those questions at the end of the presentation. And the presentation will be sent to you also as a PDF after the webinar with the link to the recorded video. Okay, so let's start with the webinar.
You have to press it twice.
Press the button. Sure. Okay. So the agenda for today's presentation is as follows. Okay. First, we'll have a few words about the intercom systems, where and why use them, and what features we should be looking for in the intercom systems. Then we will proceed to discuss the intercoms in some real-life situations with help of Michał, how the intercoms can enhance the safety, shorten the reaction time in some critical moments. Okay. We'll conclude the presentation with the summary and a short Q&A session. Okay, so again, if you have any questions, please feel free to put them in the Zoom chat. And if there's a situation that we are short on time to answer the questions, we will come back to you by email after the webinar. Okay, so maybe first words about Ambient, who we are.
Yes, okay, so we are Ambient System. We are placed in Gdańsk. We are fully Polish company. And we manufacturing, developing, and managing the products from our portfolio here from Europe, from Poland. We have over 10,000 already done projects around the globe. Most of them, of course, in Poland and Europe, but also Middle East, near and far Asia. And we started also our expansion towards the South America. Right now, we are known by products as voice alarm, according to EN54 standard. And recently, a few years back, we started to develop the two-way communication based on SIP 2.0 IP Intercom, which I'm the product manager. And well, that's all.
Okay, all right. Now, the first question to answer is where and why use intercoms, IP intercoms specifically at all, okay? So in our thinking in today's presentation, we'd like to focus on three different types of locations. First, stadiums, then shopping malls, and finally, car parks, underground parking specifically, but also. Each of them have different acoustic conditions, usually difficult conditions, a high level of background noise as well. Okay, so there are challenges we have to face. So also in case of critical communication, mobile phones are often not the best solution to report an emergency. For example, maybe you don't have the number to call, or you might just lack reception and your phone doesn't work anyway.
Yeah,
okay?
the public number is you're calling to somewhere and you have to describe where you are, what's going on. It takes a lot of time. It's the waste of time.
Exactly. So in the critical communication scenarios that we cover here, the connection must be 100% sure, okay? And the response from the other side must also be fast, okay? So each minute is important, and the idea that you want to shorten the reaction time as much as possible, get the security or medical services on the spot ASAP, yeah? So that's the basic premise of critical communication. And considering all of those points, the main features that we are looking for in the two-way communication system is, number one, you want ideally the communication system to be as simple as possible. Okay, so for example, one clearly marked button to enable emergency call directly to the operation center. Number two, you need to make sure that the voice is loud and clear on both sides. So the loudspeaker must have enough power to cut through the noise. And at the same time, it will also be great if the intercom can adapt the volume depending on the surroundings, so that the speaker is not too loud when the area around is quiet. Number three, the operator in the control center must be able to hear the person speaking to the intercom. So the device should be able to filter out the background noise and adjust the microphone volume also automatically. Number four, in critical communication, you need 100% guarantee that the system works as intended every time, 100%. So the system should have some remote monitoring and built-in redundancy so that it doesn't fail, for example, due to a network error or power failure. And finally, number five, intercoms are also often mounted in public spaces, so they should be resistant to vandalism and heavy and harsh weather conditions and damage in general. Okay, so these are the basic premises that we are working on for the critical communication, two-way communication system. So, Michał, in terms of those points, what features, in short, would you say that Ambient System has, and maybe some other things that we need to consider also in the intercom systems?
Okay, thank you for this question. I must say that let's say, allow to correct communication between 2 points, we need to consider not only just the communication, because we know residential solution for that called intercoms are also existing on the market, and they're simply working like that. You're in front of the gate, pressing the button, someone from the other side asking who's there, you answer me, bzz, open. In normal condition, that's enough for a residential area. But when we are considering the emergency situation, especially involving some kind of injuries or third-party person or any other kind of danger, we need to describe the situation. We need to add additional information toward this audio path to be sure that the help will come prepared and fast enough to solve the problem. That's why, as an ambient system, we're providing several features inside each of our endpoint user reporting station as an intercom platform. And one of the most crucial things are the algorithms that we prepared based on our understanding, based on our experience of the world of acoustic from the PAVA systems. We are developed the 3 standard algorithms that improve the general speaking intelligibility of the communication. The first one is automatic volume control. You mentioned that the intercom station need to be simple as possible. Most of the time, one button only. So there is no place for additional controlling of the volume. But we know that the situation is dynamic and the overall background noise can change. That's why the device itself on site needs to adapt to that changing conditions. So this is automatic volume control, but this is half of the equalization. So another half is the adaptive noise reduction. This is a solution for the receiver of the message to cut off the noise, the mentioned noise before, from the audio path to clearly understand the message and the information that this message provides.
Okay, so the full DSP
is on board. Okay. And the last one developed by us is automatic gain control. It's because this dynamic situation is dynamic. So the person who's reporting the situation just moving around, changing the distance from the station. So the device needs to adapt to that situation as well. Okay. This is about the DSP, but this is not all, and this is not enough.
What else?
What else? If we are talking about simple reporting, we can also use locally integration with the input and outputs that are provided with the intercom and protocols that we provide with our solution to visualize the station, visualize or integrate with other security system to provide maximum information in short time to the operator to decide what to do. This is about the seamless integration and IO control. But the last one is also crucial, the reliability and availability. This is a thing that when you are thinking about this kind of solution, this is the point in the middle of the town, for example, that's barely used because it's used only for the emergency situation. As an operator of this system, you need to know, you need to be sure that this device is fully operational. So this device needs to take self-diagnostic, needs to report its state to the upper level system, to visualization system, to show that it's ready to serve in the time of need.
Okay, I think we'll have some opportunities to discuss this in actual examples, how this works in practice. Oh, okay. So, okay, the whole kind of the technological stack is not only the outstations, the intercoms, but there's much more to it.
Yes, the thing that I mentioned, it's mostly covered by endpoint device, but the stack of technology and device that Ambient System can provide, it's not only the endpoint devices. We provide the whole solution, whole environment regarding the emergency communication, from PAVA solution for mass notification to the large area or large amount of people directly, and intercom solution, of course, with the management server, with the integration platforms, with the visualization software. Everything can be done and everything can be integrated together within our environment. This is the strength that we try to show to our partners, show how good it is to integrate and simplify the end user experience by let's say complex solution regarding the security integration.
Yeah, so basically when the person using the intercom only sees one button, but behind that button there's a lot of technology,
exactly.
Servers, network infrastructure, a lot of software, and we provide the whole system.
Of course, exactly.
All right. Okay, let's maybe proceed to discuss some scenarios. Actually, examples that we prepared, real life situations, we could say, and we prepared 3 examples for this today presentation. And we'll start with the first one, which will be a sports stadium. Okay, so let me take you through the scenario. So imagine there's a high attendance football match, and suddenly there's some smoke detected in the tribune, and the smoke is noticed by the spectators, and people, of course, have raised attention, but there is no strong reaction from the public, because in the stadiums it is quite common that football fans use, for example, smoke flares that generate a lot of smoke, but may not essentially be an immediate fire hazard.
Yeah, it's very common in Poland, at least.
Yeah, in Legia matches and others as well. It's true. Okay, but this time it's an actual fire, okay, a real fire. So the fire alarm detects the smoke and the alarm is triggered. Then the dispatcher in this control center uses the video monitoring system to confirm the fire visually through the camera, and has to prepare a coordinated response to the situation. Then he can initiate the global evacuation macro on the PAVA system, for example, the SmartVest ambient system, which then kicks in, takes control over the audio of the station and just overrides all other audio to give the evacuation message. Then the PAVA loudspeakers broadcast the evacuation instructions to the people in the stadium. And what is important, the evacuation is phased, so that each sector of the tribunes is actually addressed separately, so that the people don't have to rush to the exit at the same time, not to create like a widespread panic.
Yeah, the panic is very common thing in the bad managed situation, and this is the most dangerous, actually the most dangerous event during this emergency. The panic of the peoples inside can
it's more dangerous than fire itself.
Yeah.
Okay, but then someone notices an unconscious person on the tribune. Okay, someone fainted, maybe a heart attack, some other words, some serious medical emergency. So what they can do is they can find the nearest ambient emergency intercom and call the operation center, use the single button, and let them know about this emergency and call for help. So imagine there's a lot of noise in the background because you have the evacuation messages from the PAVA system, very loud. And you have
just because there are plenty of people surrounding, so this is noise anywhere.
Yes, and there's a lot of just the evacuating ground. So, but despite this, the caller can be heard by the operator thanks to the built-in DSP features in the intercom. So the algorithm cancels the background noise and amplifies the caller's voice to the operator. Then the control center, of course, receives the SOS calls and they have a CCTV pop-up integrated to the VMS of the intercom and the caller, so they have visual on the side of the person that is calling. The operator can then dispatch the medical team. Okay, so in this situation, again, we have evacuating crowd, and the paramedics cannot really easily reach the injured person because there's the crowd, the people are going out of the stadium, okay, and they have to go kind of against the current of the crowd. So what they can do is to use a service door to bypass the crowd and reach the injured person as quickly as possible. Okay, so the operator then has the possibility to open the gate remotely. For example, they can use the relay built in the intercom system, send a DTMF code to open the service gate for them remotely from the operation center. Then the person can be located by the paramedic team, and they can use the same service gate also to carry out the person out of the stadium and into the ambulance. So here we have a kind of the unified safety architecture example. So where you have the PAVA, you have the intercom, you have the physical security system and monitoring system working together so that everything is kind of visible and audible in the operation center. Okay, so maybe let's break it down, the scenario. So maybe a few words on the PAVA system first. How do you make sure that the audio from the PAVA system is both loud, okay, and easy to understand? Because we have the issues of the speech transmission index in like high scenarios.
I'm not PAVA product manager, obviously, but I have quite experience with that as well. So basically, when you're commissioning the whole system, of course, you're considering the situation in which there is a running ventilation, but in most of the cases, you are not able to simulate the crowd inside. That means we have to consider a situation that even during the commissioning, everything's fine and the CI index is above 0.5. But in actual event, especially if this is emergency event, this whole situation might change. That's why we developed the Smart Vest solution. This is basically the PAVA solution for mass notification equipped with the zone microphones that allow us to monitor the changing, the shifting condition of the acoustic space that we want to, let's say, spread the message within. And so this is basically the situation. Another thing that we have is the speech temporary transmission algorithm. This is a very useful algorithm that slows down the speech in the situation when operator is in stress, and it starts automatically. It starts to speed up the messaging, the spreading of the information, if it's of course done by live connection. So this algorithm can slow it down, make it more understandable to the crowd. And in the combination of those two algorithms, we provide the better solution to, let's say, provide the end message to the crowd and support the evacuation, of course.
Yeah, so would you say that the Smart Vest is probably one of the best-in-class systems for the PAVA solutions now?
Yes, definitely. We are one of the best in class, especially when we are looking about the large project that we are holding right now in our hands. We are the guys who big partners trust.
All right. Okay. But of course, the focus on this presentation is not the PAVA system. So if you are interested in our PAVA systems, then we have separate webinars, and also you can check our website at ambientsystem.eu. And yeah, and that's enough about PAVA for now. Let's go back to the intercoms. Okay. So with the intercoms, we are facing similar problems with the speech transmission. Okay, so how do you make sure that the voice for the intercom is clear? You mentioned the DSP, so maybe we can enhance this a little bit, how this actually works.
Yeah, exactly. This is done by the algorithms that I already mentioned before. But to dive a bit deeper in that, we took the experience from the voice alarm that we gained over the years of developing the PAVA and SmartVest itself, and we tried to adjust this experience to the what to say, the small factor, the small amount of computing power inside each of the intercoms, the very limited space and computing power. But we managed to do it, and that's why we provide three main algorithms to that. I already mentioned algorithms as automatic volume control. It's not only the wideband automatic volume control up or down. We also divide the spectrum to the parts in which the intercom can detect the, let's say, where the most of the noise comes from which frequencies, and it's try, of course, to adapt and increase only in those parts in which this is necessary. This allow us to save the power, and this allow us to make it much more, let's say, understandable toward the comparing to the let's say full bands up and down voice control, volume control. This is the first thing. The second thing, this is adaptive noise reduction. Of course, we are talking about the noise reductions. This is mean that it's not entirely cut off, but it's let's say this background level of the noise is limited. It's suppressed by the algorithm, and the intercom itself detects the person that sits in front of the algorithm, in front of the device, or it's in the let's say short distance to it, and can detect the difference between the noise and the voice of that person. So this is how it works. And essentially, we provide the message, the information from the messenger to the receiving point of the communication. And the third one, automatic microphone gain control. I mentioned the short distance. This is because we are talking about a few meters ahead, a few meters apart from the intercom, in front of the intercom, in this, let's say, a bit close area. But in this area, even if it's limited, we have to adjust the volume, the automatic gain control accordingly, sorry for that, to the place where the reporting person standing right now, because it can start the communication by pressing the button. It's directly in front of the device. But then this person moves a bit further from that intercom because there is a person that needs help, and it starts to communicate, maybe starts to scream. This thing needs to be also managed by the intercom itself, because this message might consist of the important information that the receiving point need to listen and understand what's the problem really is. So this is basically about the DSP that we are working on.
Yeah, it's a complicated equation, because both the background noise intensity might change, the distance of the caller from the intercom might change.
Yes, and everything in the same time.
At the same time, yes. And as I understand it, also it all works on the edge, so on the outstation, and it is not connected to the central server.
Yes, every reporting device, every IP intercom is equipped with those algorithms on board, because we don't have a luxury to send the package of the information to some kind of central server, computing that there and serving that back to the device, because it takes time, it creates latency. Of course, in the short network, this latency is short.
Okay.
Yes, but if we are talking about extremely large, complex buildings or groups of buildings, we are talking about wide networks. And also we are using the network that already exists in the infrastructure. That means there are kind of problems with that network itself might exist. So this is how, and this is why we decide to put everything on board this local device.
Okay. Good. I think that answers my question. So the next one, okay, in case of fire, let's say, there is also a possibility of a power outage. Okay, so how do we make sure that the system actually works in the case of a power outage?
Yeah, that's a very good question. From the power world, we are obligated by EN 54 standard that we have to provide the additional power source, but this is basically for PAVA.
Yes.
The intercom, this is a bit more trickier because in the different countries there are different rules. Here in Poland, we have, let's say, we start to create those rules right now for this kind of the, let's say, intercom emergency systems. But we have examples from the Germany, we have examples from the France, from the Great Britain, in which there are different kind of rules and different kind of requirements regarding the power source. Simply speaking, our intercoms can be powered from our PAVA, directly from our PAVA system, because we manufacturing both, and we prepared that for the situation. This is
like an extension to the PAVA system.
We can look at that like this situation. This is one thing. Another one, you can use standard UPS, the same that you're using for power up your or saving your servers or your computer in work, in office. If there is no regulation to that, we are not only talking about the emergency regarding to fire event, but also all kind of others emergencies that might have place in various situations. And the last one, no backup power. Because, well, as I said, in some part of the world, there is no necessary for the backup power because this kind of communication, it's not necessary from the point of view of the security manager. Of course, we are not suggesting that, but this is how the truth looks like. We can just say that our solution is prepared to be powered by, if we are talking about endpoints, of course, the 12 volts DC, 48 volts DC, and of course the PEO. So we have three ways to power everything up if we are talking about the endpoint device.
So in general, I would say the system is flexible. So whenever you need to have backup power, it is possible by two ways.
Or if various types of ways, actually, yes. We can suggest something regarding to your specific needs or to the project needs if it's right on them.
Okay, good. Next question. Okay, so you can see that use the intercoms in difficult sound conditions and even during power outage. So we have that clear. But the whole kind of security system has many subsystems as well.
Right.
So how do we integrate the intercom system within the broad scope of the integrated security system? So you have like BMS, VMS, PSIM, and so on.
Well, thanks to that, we are using TCP/IP, let's say, stack of the technology, let's say, of the environment and communication. We are able to integrate it remotely, seamlessly with the software, with usage of the protocols like SNMP, or we of course prepare the REST API for much, let's say, more advanced integration. But this is like halfway. For the very simple solution, or for the solution that don't need any other integration, we also can do it locally with our interfaces. That's inputs, outputs. We have 6 general purpose inputs or outputs on board. We can decide through the web server how we want to program them. We have 2 relays. We can, for example, as we mentioned before, connect our intercom to the local controller of the access control system, and of course the access control system managing the whole let's say communication within the building. But if there is a person without standard access and want to go inside or need to go inside, it can press the button, communicate with the operator. Thanks to the integration with other system, for example, operator can see the view from the surrounding CCTV cameras on the visualization. So everything can be done automatically. The receiver will get the full patch of information, not only audible, but also visuals and others, and can decide how to act. For example, can press the button, open the relay or short the relay in the intercom, and then simply open the door for that person.
But like in the case of the stadium, for the
exactly, this is exactly the situation. Other things that can be done, we can integrate the systems or the part of the devices that are not normally integrated or monitored. This is a good example with the hearing loop systems for the peoples of needs. With the hearing losses, we can integrate external amplifier for that kind of the system. We can provide it audio from the line output inside the intercom, and we can receive the general or specific error output from the amplifier itself. So it's not only the supporting or with the audio the device, but also receiving and reporting further the information about the state of that very device.
Okay, so that the system, the intercom can not only function like an aid point, but it can also function like a hub of sorts for other devices.
Exactly. And we like to think about this situation in which we have a security point equipped with the various type of equipment, for example, the extinguisher or some kind of fire blanket or other things that can be all of those can be monitored by contractors, by other means of the sensors, and connected to the intercom itself. And the intercom is responsible to report this states to the upper level system because it's redundant, because it's let's say self-monitoring, and because it's integrated up to the upper level system directly.
Okay, good. So I think that answered my question for now. Okay, then the first next question would be in stadiums. A lot of people have like high emotions, sometimes high testosterone. So imagine there is a high risk of devices being vandalized. Okay, so some of the devices may need to be also installed in difficult conditions outside. So you have hard weather conditions, you have high temperatures, low temperatures, high or low humidity. So can you say that the intercoms are vandal-proof and weather-proof, and what ratings they achieve maximum?
Well, in our portfolio of products, we have several, let's say, resistant intercoms designed for the withstanding the harsh conditions that you mentioned, from minus 40 degrees to up to 65 degrees of Celsius, through the AK10 vandal, let's say, resistance, and IP65 up to IP67 actually waterproof and dustproof resistance. And we are talking about from the right eco-strong device. So this is a thing that we can use in the external areas, in the place that we want to be sure that this intercom will withstand the harsh conditions. Eco-emergency version with the one button, this is the S01 version. It was initially designed for the tunnels, and it works perfectly there, but there's no let's say obstacles to put it inside the specific areas, inside the sports avenues or anywhere else, to provide the communication in that for the emergency situation. And it also can withstand harsh conditions. I like it's IP67, it's IP65, and it's vandal-proofed to IK10. And for the atrium or some kind of reception, or for the places in which we as visitors might want to have some information, but somehow we cannot manage those information or cannot get this information by ourselves, we also have this information pillars. It can provide you both the information and SOS functionality. So this is clearly distinguished between which you pressing the button, the blue one and the red one is quite understandable for everyone.
Blue for info and
yes, exactly.
For the
simpleness in its finest. Yeah, so this is the device that can be placed inside the atrium, outside the, let's say, green area surrounding the sports hall, anywhere you as a product manager, as a security manager, decide that this is the place where people might looking for the help, looking for more information, or want to report something.
Okay. Now we also mentioned auto diagnostics, and can you maybe brief us why is this important and how does this work?
Of course, auto diagnostics. These devices should be always online and always ready to serve. But because of the main reason of their existence, that means there's some kind of emergency, in most of the cases they are not in use, hopefully because there's no emergencies, of course. But we need to know that this device is ready to be used anytime, anywhere. And if it's not, it needs to report its status to the upper level system, to the visualization center, to the operator, that this operator can plan the technical visit to that very device to check what's going on. Is it just a chewing gum inside the microphone, or it's the problem with the network, or whatever else it is? It needs to be solved before actual needs of use of this device. And because of that, the auto diagnostic is very important, because the device can constantly check its connection to the internet, connection to the server, its audio path with the microphone and the speaker, if it's operational or not, the status of the inputs and outputs, if they are activated or deactivated or long pressed, everything need to be monitored, logged into the device, of course, but also you need to have a, let's say, way to bring this up above it and show somehow in the let's say easy way to understand to the person that is in charge of the security of this very place.
Okay, so that the operator, the manager of the facility does not have to send a service person every week to check if the intercoms work.
Exactly.
Basically, they have it on the screen. And the auto diagnostic features is that basically whenever there's a problem, they will get a pop-up and say, okay, you have to send a service guy.
Limiting the amount of this regular services that need to be done, you know, to every device. You're just focusing on the devices that's reporting some kind of problem, because, you know, this is electronic. This can always get somehow wrong. And the thing is that we need to be sure that the device will inform you about this situation. Of course, the device itself and the server, because if the device will be cut it off with the power, the server need to report the information that, okay, I lost this very device. Let's take a look someone about that. So this information also need to be reported, because right now we are focusing on the endpoint, but this is a, let's say, whole environment.
All right, good. Works for me. Let's proceed to another question. Okay, maybe let's bring it all together. So what kind of technology stack we would need to implement to achieve this functionalities described in this scenario specifically?
So basically we need the mass notification, or a way to mass notification. This is basically the PAVA. Everyone can listen and hear what's going on, but also we need to manage the individual situation. We need to manage the accidents that might happen toward single persons. This is where the intercoms comes in. And of course, in our modern world, we have plenty of information from all the systems surrounding us, not only ours, of course. So we need the way to manage those information, because if we are overflowing with the information during emergency situation, the people will die. That's why you need the visualization software and advanced algorithms or procedures that will gather the information automatically about the very situation that you want to take over. And only the person in charge will decide what to do according to this automatically gained information.
Okay, and from the ambient side, what kind of devices you would propose for this situation, for this scenario?
For big projects, especially for the shopping malls and the sports stadium, we are talking about smart vest solution as a PAVA. We are proposing the intercom as the endpoints. I mentioned already strong unit. I mentioned PHP, public health point, the pillar with the two functionalities, info and SOS. Of course, we need the managing server. It's a core for the managing the intercom system, and system gateway as a platform to integrate the voice from the intercom and the PAVA itself. And above all of that, need to be some kind of visualization and integration software. This is the yellow platform or software that we can offer as well.
Okay, so that would say that would be the full kind of technology stack from the intercom and PAVA side.
We are looking at this as the holistic approach to the problem.
Good. All right, so imagine this would be the example of architecture from the system, from the PAVA and intercom side, yes?
Yes. Basically, what we see is that everything can be connected together, of course, a bit divided to the part of the fire related. This is, let's say, red lines. This is a bit of a simplification, because, of course, 100-volt lines are analog one. But when we are thinking about the integration, or we are thinking about those two systems, we need to take a, let's say, a look into the fireproof cablings and requirements regarding N54, at least in Europe. And of course, the network infrastructure that can be redundant, can be let's say, supported with the additional power.
Power.
Yeah, this is a great example of how we are using our system gateway. Actually, I will cover that in a moment. So basically, let's get to the another.
Yeah, let's give you another example. So scenario number two, we have not a very uncommon situation where a child gets separated from a parent in a shopping mall. Happens to everyone. I know I was lost as a kid many times as well.
Me as
So
well.
imagine that. Yeah. So in this case, mall, high pressure environment. There's a panicked parent who then sees like an emergency intercom and triggers the intercom to call the operation center. Okay. Then the physical security platform in the control center identifies the specific terminal ID, and the video monitoring system like swings the camera to actually put the visual on the parent to the operator. Okay, so then the operator can talk to the person and calm them down and start the search process. The operator can act as a hub. So say can record the child description from the parent and push this recording to the security guard so that they know who they are looking for, and then you can use an IPBX bridge to do that. At the same time, the operator can also initiate a targeted zone announcement via PAVA system. Okay?
Exactly.
So they can page, for example, only the sector of the mall where the actual child's probably lost in, and not kind of the whole area with the parking lot and so on. Okay, they can also address individual shops and so on wherever you have the PAVA system installed. Yeah, so the security guards can help locating the child and return it to the parent. Okay? Again, we have this kind of unification of the intercom, video, and the voice alarm. So it's a bit a similar situation, a bit similar scenario. Again, we have
yes, but take a look that this is not related to fire. This is like everyday situation that might happen inside this building, and we need to somehow handle it. And there might be a plenty of situation, and we want to somehow change the working condition of the PAVA, for example. I think that we'll cover that in a moment. So maybe just let's go to the other questions. Yeah.
Okay. So another question here would be, okay, we propose the IP intercoms for emergency communication, but maybe we could use just regular intercom, like the old two-wire technology. And what kind of advantage does the IP intercom give us in the context?
Yes, two-wire technology was good. That's the short answer, but it's not enough for the modern situation, especially if we are talking about limiting the cost of creating the infrastructure. Every new building, an existing one, every time it's refurbished, it's equipped with the networks. And this network is a perfect backbone for the communication of any type of systems, actually. Not only the CCTV, that's obvious, but also it can be used for the intercom. This is why we are using SIP 2.0 standard protocol to communicate our devices. And this is a thing that you cannot achieve with the two-wire solution. But this is the half of the, let's say, situation. The other half is that because we are using the network IP protocol, we also, let's say, obligated, or maybe we are forced to use much more advanced computing processors. And here's come the space to add some on-edge computing power for DSP functionalities that are not that advanced on two-wire solution, because it's simply not necessary for that very applications. And the integration. With two-wire, of course, you can integrate the device as a server of this two-wire solution, but with the IP solution of the intercoms, you have a possibility to integrate every endpoint, to monitor every endpoint, and not rely only on the server itself. And you can even create a situation in which, if something will go wrong with the server, the communication is still here with this IP direct connection built in the edge devices. This is a unique feature that two wires cannot handle.
Okay, so 3 main points to differentiate it from kind of the older technology. Okay, so in this case, how the IP intercom to talk to the other security systems? What kind of protocols you would use to connect the IP intercoms to the broad security network?
Well, we are using the SIP 2.0 protocol as a standard communication. That means we are able to communicate with any, that's virtually, of course, but from the point of view of the protocol, any third-party provider of the SIP communication solution, we can integrate with the different types of the manufacturer regarding the PBXs, or we can communicate through different parts and different types of the IP telephones that are on the market. This is not necessarily in one manufacturer. It can be various types of manufacturing sources, because it's easier, it's cheaper, because it's a very common situation in which in the projects they're adding some new device, some new security related devices to existing somehow infrastructure, and they ask us how we can integrate together, and we answer them, it's fine as long as you're guys using VoIP, talking with SIP 2.0, we can do it. This is about the voice communication. But also we're providing the ways to integrate, let's say, this visualization commonly spoke today. So we are using for the every edge point the SNMP protocol. This is quite old protocol to be honest, but it's still very popular in most of the platform for the visualization, still using this protocol. So why using something fancy and let's say unreachable when you have this solution? But of course there are some kind of security concerns that might take place. So this is where the REST API with the exchange of the keys comes in, and this REST API, of course, for more advanced integration, is also much more secure, and we can support that solution as well. So this is basically when we are talking about the integration with different third-party system. But we also have a platform, the system gateway that you can see, guys, right now on the screen, to integrate voice and intercoms, voice from the PAVA and the intercoms solution. The thing that you heard during our presentation, it was scheduled message that was programmed on the system gateway that was distributed through the PAVA solution, because we have to understand that PAVA, the voice alarm, is meant to be used only during the related to the fire event.
Yes.
And it shouldn't be changed after the commissioning, especially when we are talking about the places like stadiums or shopping malls where there's plenty of people every time. But the reality is the end users, there is often situation in which they want to change something. They want to add a new message. They want to create some scheduling. They want to change the let's say speaker line rearrangement. We, with the good planning of the PVA system, we are able to let's say take all of this commercial requirements, all this commercial related features outside of the voice alarm, actual voice alarm. We put that inside the system gateway platform, and we allow to the end user to use standard IP phone to make a call directly into the voice alarm system without risking the change of the evacuation routes or configuration. So this is a bit advanced, and this is something very unique on the world.
So in 2 points, I would say you keep the PAVA system, fire system intact, but you add some additional PA functionalities to the existing system while keeping it according to the regulations.
Yes, you're as a designer clear in mind and soul, because you're sure that this evacuation procedures are kept safe, and end user is happy because there is a way to manipulate this device, to manipulate the system as a whole, and they can add the new files, they can create the scheduling they want, they can integrate the NTP server, they can rearrange, of course, only for this commercial solution, rearrange the speaker lines. Because you can create virtual groups of the speakers. Of course, it's depending on the design of the system, but we are able to do it with a proper design, proper allowing of the this functionality to the end user. Everyone can be happy.
Okay, and number two was the open protocol. So with the usage of general protocols in our intercom system, you can integrate it with other systems in an easy way. Because again, if they're using generally available protocols, then the integration works on the same ones. And
Yes,
which are
we are talking
which are
SIP 2.0 and SNMP. This is an open protocol
yes.
both. REST API, of course, this is maybe something more private,
Mm-hmm.
but we want to keep it private due to the security concerning, and well, we want to be secure.
Okay, let's proceed to example number three. Okay, underground car park. So we have a situation when a member of the public discovers a suspicious package next to one of the pillars. And okay, so the underground parkings are kind of notorious dead zones. Okay, so they do not have any cell phone reception. They cannot call anyone, rather traditional measures. So what they can do is they can activate again an emergency intercom, and they can instantly reach the operator. Okay, so they press the button, the PC triggers the call event in the video monitoring system. So the operator doesn't even have to search for the camera. Basically, he gets the pop-up of the visual of the situation on his screen. And yeah, and he can see the caller and he can locate the caller automatically from the security system. What happens next is the operator can dispatch the response team by the IPBX by calling the dispatch team. And what they also can do is they can use the smart Vespava again to make a targeted announcement only to the parking lot. Again, we do not want to cause like a widespread panic, but if they use a targeted announcement, they can just limit the evacuation message to the parking itself. Okay, and yeah, so I think again we covered a lot of those things already, but just to wrap things up, in car parkings we have the situation. Maybe the situation is not as difficult as in stadiums or shopping malls, but do you still need active DSP for basic parking lots?
Well, it's again the dynamic change environment. We are talking about the mass amount of concrete, of course, below us, but also above us. So there is an echo in the communication. There is noise from the engines. There might be noise from the crowd if there is someone else in the parking lot. So we basically speaking about the same, let's say, challenges that we have to solve somehow from the previous type of the not experience examples. Yes, that's the word. Sorry. So yes, but definitely we need the DSP here as well to improve the communication.
Okay, short answer to the point. And finally, okay, so let's say the car park operator does not want to have a dedicated wall-mounted intercoms in the car underground parking. And we already have often use a two-way communication system integrated into the parking payment stations, okay? So is it possible to have a solution that is integrated into the payment machine? And will it have the same features as the emergency intercoms?
Of course, it is possible. We have an eco box for that, as you can see. And this is basically our electronic equipped with all functionalities that you can just build inside the third-party device at the microphone, speaker, and some kind of button. And you can be happy with using of the DSP functionality that I mentioned before. And of course, any other features that is on board of this device. So I mean, the relays, the inputs and outputs for the audio, and of course the general purpose inputs and outputs. So you are able to do it freely with that device.
So essentially, it's like a normal intercom, but just in the context of a bigger housing. It will still have the security, will still have the DSP, will still operate on the same kind of network.
Exactly. As long as you're using it according to the manual, because you have a free way of using the microphone and the speaker, and there is some kind of limitation of the distance between those two. But if you keep with the manual, I'm sure that everyone can use this functionalities with a very good, let's say, very good approach. Well,
okay. All right.
Yeah.
I have to actually, English is not our first language.
Yeah, exactly.
Okay, because also in the car parks or in other situations, you already have some existing network infrastructure. Okay, understand it is possible to use the same kind of network infrastructure or one put next to it as used for the CCTV cameras that I also work on the
Exactly.
on the IP.
When we are talking about some kind of edge device regarding the management of the network, we can just connect to that edge device. Of course, it's necessary to communicate that to the IT security guys and
Yes.
the team that is responsible for the networking. But it's not changing the infrastructure, it's just changing. It's not building the infrastructure from
Okay.
zero, it's just adjusting the infrastructure, either by only changing the rules, like, for example, creating the VPN or VLAN connections, or extending that from the nearest points. So this is much easier and much simpler, and of course much cheaper than creating the whole new infrastructure by yourself.
So when you have a network infrastructure, in short, you can use the IP intercoms, and you don't have to lay one from new, like in like a two-wire systems, for example.
Exactly.
Okay. It's time for the Q&A. Let's check maybe if we have some questions on the chat.
Yes, let's check the chat, guys. This is the last chance to add some question. Right now, I don't see anything here. I see that we a little bit extend this time, so maybe we covered everything that people would like to ask. So,
if you have any questions, I'll give you also our contact data. So this is the end of the webinar. Thank you again for taking the time to participate and listening to our discussion. On a final note, I'd like to just stress that we understand that each project is different and we'll have many possible integrations. And basically, you need to design it individually every time. So we are here, Michał and I, to assist you with this. So we have a project that you want to use the intercoms, where you see the need for the intercoms. Just let us know. We'll help you and advise the best solution, the best integration.
And of course, it's not only us.
Of course, the whole company.
There's the whole team for the pre-sales and post-sales. The guys are ready. The pre-sales, of course, they are ready to discuss to you the possibilities of your project, and the post-sales will support you once you won the project or once you start the installation process and you have questions regarding how to configure things. They're ready to help you anytime. Well, just call us and or visit us here in Gdańsk in our headquarters.
Here we have our contact details, email, telephones. Okay, so feel free to drop us an email, give us a call anytime. Yeah, we'll be happy to come back to you. All right. Thank you, Michał. It's been a pleasure. Okay.
Thank you very much, and well, have a great day. Let's end this.